Good morning to all. Myself Dharanika, working as Assistant Professor in Artificial Intelligence from S.A.E. Engineering College. Today I am going to discuss the concept about PRIM's algorithm. Introduction. PRIM's algorithm was developed in the year 1930 and also it can be involved in the techniques like greedy algorithm. Greedy algorithm means we have to decide what to do in next step, and this PRIM's algorithm we need to find the minimum spanning tree path for all the undirected graph. Here we have to discuss the basic concept about minimum spanning tree. First of all, we have to see the spanning tree. Spanning tree means we have the undirected graph. This is the example part spanning tree. This is the undirected graph. We have to have all the vertices are connected with undirected graph in each node and the edges. In this, we have to find the minimum spanning path for all the graph. This is the example graph for minimum spanning tree. In this part, they have to explain about the spanning distance for possible ways. Here in this example, there are three possible ways for spanning tree. For this example, they have to interconnect with A to C, C to B, C to D, and C to D. Spanning tree means we have to find the minimum distance for each possible distances. In this spanning example, have three possible ways. These are the example ways for first possible distance is A to D nodes are connected, and D node is directly connected to C node, and C is connected with both B and E. This is the first possible way. And second possible way is C is the intermediate node for all B and B, A, B, E and D nodes. And the last possible way is A directly connected with D and A directly connected with C, and C is directly connected with both E and D. And the next concept is about weighted graph. Weighted graph means the nodes and vertices have weighted values for all the edges. This is the sample example for weighted graph. And next topic is about minimum spanning tree. The minimum spanning tree means the graph having the undirected graph only, and it can be directly interconnected all the nodes and edges with undirected graph, and under the concept of spanning tree. The spanning tree means already we have to discuss about the spanning tree means to find the minimum distance for each undirected graphs. This is the concept about the minimum spanning tree. This is the example one for minimum spanning tree. This is the directed graph. In this example, I have to taken first example is directed graph and another example is undirected graph. Here we have to first discuss about the directed graph of minimum spanning tree. Here we have to taken the example like 1 directed graph to 2. And this distance between 1 and 2 is 2, weight value is 2, and 2 is directed graph to 3, and 2 and 3 intermediate weight value is 3, and finally 1 and 3 is directed map with weighted value with 10. This is the sample example for minimum spanning tree directed graph. We have to using the techniques of minimum spanning tree, so that output will be the here we have to compare with this distance. First 1 and 2. This 1 and 2, the minimum value is weighted value is 2. So we have to take the node value of 1 and 2. Intermediate weight value is minimum for 2 distance only. So here we have to take the 1 and 2 for minimum spanning tree example. And then we have to compare with the node 2 and 3. In this 2 and 3, the value is minimum with the weighted value is 3. So here the output will be come to 2 and 3, the node is the 3. Here the 3 to 1, the minimum value node is maximum value of compare with these two nodes. So here we didn't take the 3 to 1 as the minimum spanning tree example. So the output of directed graph in this example 1 to 2 and 2 to 3, total weighted value is 5. This is the example 2. This example 2 is already I discussed about. Example 1 is the directed graph and example 2 is the undirected graph. In this undirected graph, the nodes are goes to all the nodes not under the priority of directions. So it can be likes under A to C or C to A to D or D to A. Just like the undirected graph. Here they have to given the three possible way for to finding the minimum spanning tree. First possible they have to take the value of A to D. Comparing with A to D, they have to take the 10 as the minimum distance value for A to D. And then we have to compare with 10 and 9, they have to taken the value for D and C node. So here they have to putting the value of D to C as the weighted value is minimum for 9 and then they compare with both nodes. So they have to putting the possible way for taking the both nodes B and E. So the first spanning tree value they have to calculate this all value and the sum of the all edges they have to put the weighted value equal to 74. And the second possible value they have to taken the values of, because already they have to taken the value for A to D. So next possible way they have to eliminate the A to D and then compare with A to C. So they have to eliminate the A to D and then compare with A to C. That weighted value is 7. And then they have to compare the values of C to D and both B to E, because they have to undirected graph with one interconnected node only. Here only the A can be interconnected with both nodes A and C. In this spanning tree 2, they have to sum all the vertices and values. It can gives only the 71. And third possible way, they have to taken again the A to D. They have to eliminated the C to D and taken A to C and both B and E. Sum all the possible values. In weighted values they get 72. Compare this all the possible. The second one is the minimum spanning tree answer. So they have to get the value for W equal to 71. The second way possible is the right one for minimum spanning tree for undirected graph. Algorithm characteristics. In this concept, it both can be involved in the greedy techniques. Greedy techniques means it can be decide what the algorithmic steps can do in each steps, and it can be mainly under in the minimum spanning tree to find the minimum and weighted value for each steps. These algorithmic steps can be both involved for PRIMS and Kruskal algorithm. These techniques are usually under the undirected graph examples only. And these both techniques and methods involved only the weighted and unweighted graph values only. And these both are already I discussed about greedy algorithms, and it can be give the maximal values for all this. Already I have to discuss about the PRIMS algorithm. PRIMS algorithm is under the greedy algorithm to find the minimum path for weighted value for present graph. It can be either the undirected graph or directed graph, or it can be under the weighted graph or unweighted graph. It mainly the principle under the minimum spanning tree. These are the working procedure for PRIMS algorithm. The first steps we have to initialize the minimum spanning tree principle, and it can be checked the vertices and the edges for randomly to implement the minimum spanning tree method. And second step, it can be calculate all the weighted values, whether it is the minimum or maximum. Compare with 2 or 3 nodes. It can be taken the minimum spanning tree method to involve all the vertices and selected the minimum value for weighted or unweighted graph. And step 3, until the minimum spanning tree function is over, it can be taken the loop for step 1 and step 2. This is the example for PRIM's algorithm. In this example, they have to given the undirected graph with node A to A, B, C, D, E, F, G, F. These all nodes are interconnected with undirected graph and along with weighted value. Here in this box is the initial array. Here we have to mention what are the nodes are present in this example, and K means what are the possible ways we have to using the minimum spanning tree to establish, and DV means what are the direction it can be goes for weighted value. The D only the mention for weighted value of the graph for interlinking between 2 or 3 nodes. And PV means which path the minimum value is occur. We have to stop in that node, in that PV. First, we have to take on the steps for initialized array. We have to initialize all the present nodes in this example A to H, and K values means we have to take on the first value for H. F, for example, we have to take on for here F, and the distance between this we didn't start any minimum spanning tree for initial array. So these values are infinity, and the path value also infinity. And second step, we have to take in, for example, here which is the minimum value which is present in the node, weighted value, which one weighted value is minimum in this node. Here we have to sample to take D. D has the interlinked between C and D. Compare with C and D. C and D and C has the minimum spanning path for weighted value. So here we have to take the path for T as the initialized one. So we have to mention the distance between this one is 0. And second path is D has the minimum path with interconnecting with C. So D to C path, we have to mention the distance between D to C. We have to mention that minimum value for that C. So here we have to put in the C, that which path it can be taken from. Here C node is main part, and which minimum part is taken by weighted value is D. So here we have to put in the D has minimum value, and then comparing with all, we have to take an E has, because D is interconnected with D and C, D to C and D to E. So we have to take the weighted value for 25 has D order, D is the part, and F has the interconnected with all bond. Next minimum spanning tree under the F to C. So here we have to calculate this all values, putting the 18 as D. We have to summation for 3 plus 3 is 2. We have to calculate this as 18 plus D. And then finally we have to putting the G has the ground value, because G has the comparing with all node, then the G has the minimum spanning tree method. So here we have to putting the G has the initialized one and putting the minimum value for 2. It can be interconnected with G to D. And then here we have to C, then we have to take in the C has the initialized path, because C has the minimum value for comparing with all the nodes. C has the minimum distance for C to D interconnected node, and it can be C path is directly interlinked with the path for D. Comparing with all graph, we have to finding the minimum value for weighted graph for all the values, and finally we have to summation the all the weighted graph comparing to the distance and the path. Finally we have to compiles this table. K has the initialized all the nodes, and the distance between the all, here we have to taken only the minimum values, and which path it can be interconnected with minimum weighted values, here we have to mention. A has the minimum value for 4 and the interconnected with path distance is H, and B has the 4 and it have the minimum value C. Comparing with all C, D, F, G, H, all the nodes have interconnected with one node to another node with a combination of minimum spanning tree. Here the complete graph is under the PRIM's algorithm. In this PRIM's algorithm, all the nodes are selected with minimum vertices and minimum distance only. Here we have to sum all the values for minimum spanning tree, because already the spanning tree means we have to summation all the vertices value in the directed or undirected graphs. So we have to calculate all the distance in this, and finally we have to get the minimum spanning tree value is 21 for this graph. This is the previous year GATE question. For the undirected weighted graph given below, which of the following sequence of edges represent the current sequence of PRIM's algorithm to construct the minimum spanning tree? Here they have to mention the undirected graph with weighted value. We have to calculate the minimum path distance for each graph. They didn't mention about the summation of that value. They have only the which path is occurs the minimum value. So here we have to calculate. First of all, we have to take the B to C, compare with B to C and A. The B has the minimum path, so 1 is the minimum value, so B to A is 1. And they have to compare with all. They have to take the D has the mid node, because the D is interconnected with all. So D to 1 is the D to F, and D is interconnected with A, and D is interconnected with G. Compare with A, G and F, the D to F is the minimum value. So we have to take the D to F is the minimum value, and interconnected with which node they have to leave, that connected node only we have to take for next minimum spanning tree method. So F compare with C and F compare with H. So we have to take the compare with FC to FH. The weighted value is here 8 and here 3. So the minimum value for this one F to C only. So we have to take the F to C. And comparing with the C, they can be interconnected with E, A and B. So in this connected graph, we have to take the minimum value. Comparing with the previous leaving graph, we have to comparing the minimum value with the comparison of all the weighted value which is the present in the minimum spanning tree methods only. Thank you.